Hi everyone, this is Dr. K. Kannan, Associate Professor, Department of ECE, R.M.K. College of Engineering and Technology. In this lecture video, I am going to talk about the basics of electrostatics. So first one, we can talk about electromagnetics. So electromagnetics may be regarded as the study of interactions between electric charges at rest and in motion condition. Electromagnetic is a branch of physics or electrical engineering in which electric and magnetic phenomena are studied. So EM applications is in physical medicine, for example, electromagnetic power either in the form of short waves or microwaves is used to heat deep tissues and to stimulate certain physiological responses in order to relieve certain physiological conditions. And EM fields are used in induction heaters for melting, forging, annealing, surface hardening, and soldering applications. And electric heating equipment used is to join or seal thin sheets of plastic material. These are the EM devices: transformer, electrical relays, radio, TV, telephone, electric motor, transformer lines, waveguides, antennas, optical fibers, radars, and lasers. Then we are going to talk about the coordinate system. So a point or a vector can be represented in any curvilinear coordinate system which may be orthogonal or non-orthogonal. An orthogonal system is one in which the coordinates are mutually perpendicular. Orthogonal coordinate systems are Cartesian or rectangular coordinate, cylindrical coordinate or circular cylindrical coordinates, and spherical coordinate. With that we have elliptic cylindrical, parabolic cylindrical, conical cylindrical, prolate spheroidal, oblate spheroidal, and ellipsoidal. So look at that, this is the Cartesian coordinate system. In Cartesian coordinate system, we are using x, y, z is the parameter. So the name of that one, it is a rectangular coordinate. And consider a point P is a common for all the x, y, z axes. So P of x, y, z. Here, the range of x is from minus infinity to plus infinity. Similarly, the range of y is minus infinity to plus infinity. Similarly, z range is from minus infinity to plus infinity. Then cylindrical coordinate system, or another name is called polar coordinate system, where the parameters are rho, pi, z. So according to this diagram, rho we can rewrite root of x square plus y square, where x equal to rho cos pi, and pi is the tan inverse of y by x, where y equal to rho sin pi, and z equal to z. So here the rho ranges from 0 to infinity, and the pi ranges from 0 to 2 pi, and z ranges from minus infinity to plus infinity. The next one, spherical coordinate system. In spherical coordinate system, where we have three parameter r, comma, theta, comma, pi, where r equal to root of x square plus y square plus z square, where x equal to r sin theta cos pi, and theta equal to tan inverse of root of x square plus y square by z, where y equal to r sin theta sin pi, and finally pi equal to tan inverse of y by x, and z equal to r cos theta. Here the range r is from 0 to infinity, theta is 0 to pi, and pi is equal to 0 to 2 pi. Then differential length, area, and volume for Cartesian coordinate system. According to this diagram, consider a cube that is kept in between z and y axis. Then we can write the corresponding equation for ds x, dx y, ds z in terms of surface. Similarly for volume, dv equal to dx dy dz. So differential length dl is equal to dx a bar x plus dy a bar y plus dz a bar z. Similarly for differential surface, dsx equal to dy dz a bar x, dsy equal to dx dz a bar y, dz is equal to dx dy a bar z. Then differential volume dv equal to dx dy dz. Then for differential length, area, and volume for cylindrical coordinate system, look at the diagram where considering a point P is common for all the three coordinate system, and we have to find the distance between the point where in the z axis, similarly for x axis and y axis, so that this diagram will get, and dl is equal to d rho a bar pi plus rho d pi a bar pi plus dz a bar z. This is for differential length. Similarly for differential surface, ds rho is equal to rho d phi dz a bar pi, ds pi equal to d rho dz a bar pi, dz is equal to rho d pi d rho dz. So the differential volume dv equal to multiplication of rho d pi dz d pi. And similarly for differential volume for spherical, so differential length is dl equal to dr a bar r d theta a theta plus r sin theta d pi a bar pi. Then differential surface dsr equal to r square sin theta d theta by d pi a bar r, d sin theta is equal to r sin theta dr d pi a bar pi, and d s pi is equal to r dr d theta a bar pi. So similarly for differential volume. Then we go for the point transformation from Cartesian to cylinder, where rho equal to root of x square plus y square and y equal to tan inverse of y by x and z equal to ez. From cylindrical to Cartesian coordinate, x is equal to rho cos phi, y equal to rho sin phi, and z equal to ez. And for Cartesian goes to spherical, where r equal to root of x square plus y square plus z square, and theta equal to cos inverse of z divided by root of x square plus y square plus z square, and phi equal to tan inverse of y by x. Then from spherical to Cartesian, x is equal to r sin theta cos phi, y equal to r sin theta sin phi, and z equal to r cos phi. And vector transformation from Cartesian to cylindrical in terms of vector form. So similarly for from cylindrical to Cartesian coordinate system. Then from Cartesian to spherical and spherical to Cartesian system. This way we can find out. Okay, so I'll stop here. Thank you for listening.